Hey everybody, this is Larry. This is me doing week 1 of the weekly October premium challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. And today, I mean, as you can see, I saw there anyway before, but I didn't look at it. It is a medium anyway. I am very tired, so we'll see how this goes. And let's go. Today we have 1135, connecting cities with minimum cost. There are n cities from 1 to n. You're given an integer n and an array of connections. Right? So, okay. We've done the minimum cost to connect all n cities such that there are at least one path between all of them. Okay. I was curious why this is red, but I guess maybe that's just to show you. I don't know, just to show you stuff. I mean, this is clearly a standard minimum spanning tree. You want all cities to connect. You want the minimum cost. It is a spanning tree, a minimum spanning tree, right? I don't really have much to add to this one today. There's a lot of literature, but I'm not going to go over the literature today. This is not meant to be a lecture, right? There's a lot of good videos on it probably because it is a very standard thing to wanting to do. Or it is like, you know, it shows up a lot in intro algorithms, right? So I'm not really worried about it. And for now, you know, but yeah, there are a couple of ways you can do it. You know, all the usual MST algorithms. The way and one thing that is good about learning MST with spanning tree is that spanning trees, of course, applies more than just minimum spanning trees. There are other type of spanning trees, like say shortest path spanning trees. And the curious thing about those things is that for me, I mean, there are a lot of interesting things and a lot of curious things. So in case you're wondering, I'm just like fidgeting with my mini tripod. Oh wow, it extends actually. Okay, but in any case, I'm just so tired. But in any case, the part that I find fascinating, right, is that it is the greedy portion, right? Minimum spanning tree is one of the first things that you'll learn, maybe along with either Dijkstra's or BFS. Where you get an idea of proving greedy. So definitely see if you can find videos or textbooks that kind of shows you in that direction. And the greedy portion of this is that, you know, the locally optimal solution yields the globally optimal solution, right? And in this case, it is by picking the smallest edge that is already not connected. Like I said, there are a couple of ways to do it. For me, for today, I'm a little bit lazy, so I'm gonna go with Cusco because I don't know. It's just excuse me. I mean, you can also do prims, but I don't know. I don't really feel strongly either way, but I like Cusco because it's easy to implement. And for that, you will need a DSU, disjoint set union, or union find data structure, right? Again, that part I'm not going to go over either for this one, but I am going to, I don't know, people have all these crazy templates for these things. I think it's not necessary. And I'll show you just like a really quick, you know, like for me, I just do right? X for x in range of n, right? Is it 1 indexed or 0 indexed? Looks like it is 1 indexed. But I wish they are more explicit about it. It is 1 indexed from here, but you know, right? But that's fine. We'll just change it on the way in, right? And then you just have, you know, union and find. Those are the two functions. You find x if this is not true, then we do a path compression, right? If, and then now we have two things for a union. We get the root of either with both of them, I suppose, and then we just set the root of one of them to the other. Though maybe yeah, I mean, I think that's technically fine, but sometimes I like to do this for things where you may union multiple times, right? And that's it, right? I mean, you can optimize it slightly more, or make your bounds more tight by having you know union by rank or union by size or something like that. But with path compression, it's still, I would say, fine. I don't think I've ever seen a time where that's not. I mean, I could be wrong, but I haven't seen a time where that's not the case. So yeah, right. Anyway, yeah. So then now it just becomes easy. We want to sort connections, right? Let's just say ye for edge. Then we have ye of 2, right? Ye of 2 is just the third item, right? Which is the cost. And that's it, right? So then now you have uv cost in connections, right? If, and I guess we, there are a couple of ways to write this. We could say that if then we return true, that means that we reunion or we didn't union, right? So then you can maybe just do, okay, if uv, if this is true, right? If this connected, meaning that this is a part of the MST, then we add the cost, right? So and then that's it. Pretty straightforward, right? Pretty straightforward and long. I forgot. I mean, I said that I would, but I just forgot. Which is that we need to convert it to 0 index. That's all. Yeah, and yeah. I also forgot the case where yeah. So one thing to and there are a couple of ways you can handle this. Really, you could, for example, you can go through all end nodes to see whether they all connect to the same root. That's one way. Another way is just taking advantage of the fact that any tree on end nodes is going to have n-1 edges. So you could say maybe connected or something like that is equal to 0. We connect it. We use this as connection, right? So if connected is equal to n-1, then and otherwise, right? Pretty straightforward. I'm just not really thinking, to be honest. And this is it's standard minimum spanning tree thing. So, and as you can see, you can there is a harder or tighter complex analysis, but you could just say that both of these are over 1 effectively amortized. But so it's going to be dominated by the sorting, which is going to be ye log ye, right? And then that's it, and everything's one by all of ones. It's pretty straightforward. What did I do last time? No, I didn't even do it last time that long ago. This is like only half a year ago. Probably did the same thing. I mean, yeah, mostly did the same thing, really. So yeah, I don't know. I mean, I guess it wasn't that long ago. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Larry needs to sleep. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.